Hi, my name is Vijay and I'm recording this video for Roughbook. In today's session, we're going to talk about views and the options that are available along with the views. So to start with, what is a view? A view can be defined as a wrapper that's written along the set of select statements, which can be having either one table or a combination of multiple tables. So let's look at the definition of what a view would look like. So here is the select statement I'm actually looking at. So it actually joins multiple tables. One is a product table and another is a purchase order table, and it gets me a couple of columns. So I would like to create a view on this so I don't have to write this query every time I want the details. So let's go drop the view if it exists. So it does not exist. Let's create a view. There you go. And to access the view, it's a normal select statement. So there you go. So I am just querying the view as I query a table. So you can even specify the column names as what you see. Like, let's say I don't want all the columns for now from the view. So I just select the product ID and name. So a view is an object that exists in the database. So you can actually go to the database, the views. So let's refresh, and this is the view we actually created right now. And if you right click on the view and say design, you can see the select statement that we have used right now to create the view. Another option to see the definition of the view is about making use of the SSP_help text procedure. So this returns the view definition. So going forward, the next one is about the schema binding and why would we need that. Let's say someone drops the product table which is underlying this view. So what happens to the view? So you cannot access that view since one of the table that is being used in the view is not existing anymore. To overcome this issue, a view can be created using the option with schema binding. So let's go into another example. I'm going to initially drop the objects if they are existing already, else I'm going to create a table called customer with 3 columns in there: customer ID, first name, last name. I'm going to insert 4 rows. So there you go. So let's just see how the customer table looks like. Good, that we have 4 rows. Now let's create a view on the customer table. So we have the view created. Let's query the view. So there you go, we have the view. And now let's alter the view which just now we created with the schema binding option. So it's still the same. Now let's try to drop the customer table that is created under the view. So now the error comes which says the customer table is being referenced by the view, and this is what exactly we want. We don't want the user to drop the table when there is a view actually created on that particular table. So this way we are restricting the users. This is one of the options that every developer needs to keep in mind while giving access to different users of other teams. So let's just clean this up. Drop the view, drop the table. So now let's go into the next thing, creating indexes on views. We all know like the usage of indexes, they improve the performance. So it happens like a view is nothing but a wrapper which is created on multiple tables, and definitely the output could be millions of rows in many of the scenarios. So the view will definitely take some good amount of time to execute. Even when these kind of situations can be overcome, like creating indexes on views. So let's look at how to create indexes on views. So I'm going to create the table, the customer table again, insert the values, the 4 rows. So I'm going to create a view. So let's try creating a unique cluster index directly on the view we just created, and we have a customer ID in there. So I'm going to create a cluster index on that particular customer ID. So it doesn't allow me. It's because indexes cannot be created on a view which are not created with the schema binding option. So I'm going to alter the view and put a schema binding option. So now let's create a cluster index. It works. And then a non-cluster index, and it works. So there are two things we got to remember here. We cannot create a non-cluster index unless and until we create a cluster index. That's one thing. Another thing, in my view, I've actually concatenated the first name and last name as a full name. So since we are creating a definite index on the view, I cannot create an index separately on two columns, first name and last name, as we have in the table. Rather, I have to create an index on the new column that is available in the view, which is full name. Okay, so now let's go into the next option, using a with check option. This is another security aspect where every developer has to remember. So let's look at an example to understand it better. I'm going to drop the table, drop the view, drop the table. So let me create the table again. Insert the 4 rows. So I'm going to create a view initially without a check option. So I'll just explain you what exactly the with check option would do. So see here, my query is having a where condition which returns 2 rows for me. I mean, it has two names with the first name as Sam but a different last name. One is David and another was an Anderson. So let me create a view on this. So just query. Okay, now let's say a user performs an update statement and updates the first name to be Vijay. 2 rows affected. Okay, so let me execute the query again, the view. Oh, it doesn't return me anything. How does the table look like? So let's start from customer. Wow, as you see, the last 2 rows are updated by Vijay. Well, that's not the result we are expecting, right? So let me just clean up the things again. Drop the view, new view we have created. Drop the table because we updated 2 rows. Create the table again. Insert the 4 rows. Let's get back and create the view, this time with check option. Now try to execute the same update statement and it throws an error. As you can see, the update failed because the target view either specified with check option. So this is the one we want, when an update statement is fired on a view with a where condition. So we don't want the user to update multiple rows with the same value. So this is another handy option that you can use while creating views in stored procedures. Okay, now let's look into the next one. Is about refresh and recompile views. Okay, we did talk about the schema binding option where user is not allowed to drop a table. So but there might be scenarios in your project where the table might get dropped and gets created again with the same name. In these cases, what happens to the view? It actually gets invalidated. The view is not accessible. The view might exist, but the table does exist. But due to the operations that happen, the view gets invalidated. So in those scenarios, the option what we got to execute is sp underscore refresh view. This command updates the metadata and makes the view accessible again. So this is something that needs to be executed at the end of the process or end of the batch. Once all the tables are published, all the tables are committed to the destination server, you just execute the refresh view on all the available views in your server. So it just updates the metadata for all the invalid views. Another handy option that every developer should remember. So a last option what we're talking about was recompile views. So in cases where whenever we try to execute a select statement, execute a stored procedure with a similar parameters, every stored procedure caches the query plan. So but having a query plan is much useful when the parameters that being passed to that particular query are almost similar. So the query plan actually gets reused, but in a condition where it is not, it becomes an overhead. So we can execute the statement which says the sp underscore recompile view. It takes the view name or the stored procedure name as a parameter. So it clears off the whatever the query plans we have in the cache. So the next time when we execute a stored procedure or execute a view, it creates a fresh query plan.